A subcomponent of design for excellence, design to cost. And aPriori gives us cost information as we design, as well as the guidance to tell us what's good and what's bad. But here's a couple of examples of where design to cost can be exploited with aPriori. This is a weldment, a series of sheet metal and plate parts welded together, and aPriori costs the parts and it costs the welding process as well to get me a should cost. But I could just as easily cast this and then start to design for castability. I can machine it from solid and all sorts. So here are three different processes. The one on the left is the original process where we're going to weld it, because that's what we've always done. That's what we do because of the low volumes we work on. However, supposing the volumes go up, like they have in this case, then from a fully burdened cost perspective, you can see here, we've gone from 3,000 if we weld it, down to 1,100 if we machine from a casting. So there's a 64% decrease in the cost if we cast rather than weld. And sometimes these opportunities aren't that obvious, but aPriori can help us find them. What it can also tell us is that if we go down a casting route and casting becomes a risky process through supply chain because of pandemics and Brexits and things, then, well, I could machine from solid. That could be my get out of jail strategy. And the cost of machining that from solid is a lot higher, of course, but I can plug that into my risk equation. Fabrication is much easier to do and there's less risk around it, but it requires tooling and fixturing. I could go straight to manufacturing from solid if the world changes and have a supply shortage. It gives me options. We do the same, of course, with the electrical world. For a wire harness or a printed circuit board, we have different design strategies we can do. So I can take bills and materials, put them into aPriori and say, how much does this board cost, including the process of making it as well, if I use lots of silicon? Could I use more passives at a greater price, but I could de-risk my supply chain, as we've seen today, and I could perhaps avoid expensive ASICs, application-specific integrated circuits. So I can compare one design version with the other, bring into the equation risk, and make decisions on which design is best from a manufacturability and therefore cost perspective. But most importantly, from a design to cost view, as aPriori is analyzing everything, as we design stuff, it can analyze it. We can set targets that we follow. So when we get aPriori to give us our costs and there are overruns, this part of the system here, the motor is overrun on cost, the blue bar shows me that. I then focus my very finite and limited resources on solving that problem, and therefore I can bring the cost under control. So the simulations themselves allow us to track where we are going off base and then bring it back to bear when we need to, in a timely fashion, of course. So designing to cost can be achieved in many ways, but what does it mean to us? Let's say 30% of my products are new every year, including my custom products. So 63 million of my COGS, my cost of goods sold, can be reduced if we avoid these issues. Let's say we take a 5.2% cost reduction or cost avoidance, say 5.2, because that's what our customers get on average. That's worth 3.3 million to my organization per year. Over 5 years, of course, that's worth 16.5. And if you look at this from a pure cost avoidance perspective, when I design something out and it goes into production for 5 years, that is real. That's a real cost saving or avoidance, which will carry on through the life of the product. To get that cost back out later requires expensive value engineering and cost reduction that I don't want to do. Remember, I want to focus on innovation, not trying to take cost out later. I want to do it today. And that's the impact I can have.